right. Thank you very much for coming to this session. I know you have a lot of choices, and it's towards the end of the day, so thank you once again for showing up in our talk here. My name is Siddhartha Roy. I'm the general manager for the AWS Hybrid Edge and Data Transfer family of services. That includes Snow, data migration and edge compute, storage gateway, the data sync services, and also the transfer set of services as well. And along with me is my colleague, Ramesh Kumar. He's the head of product and solutions at Snow, and he's going to be coming later in the session. So today we are going to cover bringing AWS to the edge, and specifically to the remote edge, right? So you have seen a lot of talks and great talks on what we are doing in the cloud. Many of our customers are asking us to extend the cloud on to the edge. And we'll talk primarily about what are the services we are deploying at the edge and how our customers are building applications, go into some of the use cases. So a quick rundown for the agenda for today. We're going to first cover the continuum of AWS services, what we call the close edge, far edge. Then we'll talk about double-click into some of the services, like local zones and wavelength. And then Ramesh is going to come up and talk to the Snow family of services and the capabilities for edge compute. So with that, let me first talk about learning from customers. So at AWS, everything starts from a customer working backwards. And when we talk to customers, they were telling us three things. The first thing is they want to extend their infrastructure to the edge. That means they want to extend the infrastructure services, the APIs, the tooling, experiences to the edge, so they can extend their cloud application to the edge and deploy their apps. The second thing is the use cases driving these edge applications are four. One is low latency, because some of these edge applications are deployed at the edge. They're collecting a lot of data. There's a need to react in real time and process the data. Second thing is there's a need to migrate and modernize from your traditional on-premises infrastructure. Third, many of these applications, because they're processing large amounts of data, think about structured, unstructured data, it's difficult to move the data back and forth from the edge to the cloud, and they need to process it right there with local data processing. And finally, with data residency, many of these customers want to deploy the services and applications in their colos. That needs to be in a certain country or state or a geo-fenced boundary location. Now, finally, what are some of the challenges for the solutions today? So often we have heard customers telling us that current solutions today are complex and difficult to procure and manage and operate. Why? Because they are from different vendors. They don't have the same APIs. The infrastructure management and tooling is all different, right? So the value prop that we provide is coming in together as a single solution, single set of infrastructure, single set of management plane, single set of APIs that extend from the cloud, and easy to procure, easy to manage and deploy. So let's cover a little bit on some of the services as we know it. On your left-hand side, you have the global infrastructure of regions. These are regions where we deploy your applications, the regions you know and love. Now, in the first click stop, we have the metro areas and telco networks. Think about many of our customers want to deploy their apps in big metros and industry centers. And consequently, what they want is to have the compute network storage be close to the applications in those industrial cities. And I'll give some examples of that. So some of the services there includes our CloudFront service, local zones, wavelength, and the telco network builder. One more click stop out is our on-premise services. Think about Outpost. Now think about storage gateway, which is one of the services I manage as well. So if you think about on-premises, these are services that need to stay in a customer's co-located environment. Essentially, why? Because they need the command and control for primarily latency and majorly data residency reasons. Then further out from on-premises is what we call the remote or rugged mobile disconnected edge. That's where the Snow family of services come in. The Snow family of services can completely operate disconnected from region. The control plane and data plane are disconnected from region. Along with Snow, we have a set of integrated private wireless on AWS services that offers a customer a telco private 5G solution, if you will. Could be built on Snow with our third-party vendors. And that also operates at the remote rugged mobile edge. And finally, we have the smart devices, which is our IoT family of services, which are essentially, think of them as your IoT endpoints, which are thousands of endpoints, millions of endpoints, which are sensory controls, if you will, which are collecting data and feeding it to the rest of the services here in the tier. A little bit about how we think about applications. Our mission is to make sure no matter where a customer starts in their journey, we want to make it easy for customers, that includes developers, to develop, test, deploy, operate their applications. And there are two kinds of developers here. One is what we call cloud-initiated. So these cloud-initiated developers and services and applications begin in the cloud. So the first design point is this application was designed in the cloud using AWS services, EC2, or containers, or S3, for example, right? And then what's happened is, over time, they figured out, I need to deploy this application beyond the cloud, close to the edge, because a lot of my data is getting created there. So think about maybe a private 5G application initially deployed in the cloud for a certain reason, then again deployed to the edge where the sensors are collecting data with the software-defined radios. The second category is the cloud-enabled. These are edge applications that start not in the cloud but at the edge, and they may or may not have AWS API integration, but they eventually want to get cloudified and take the benefit of the cloud in terms of monitoring capabilities, observability, and other things. Now, double-clicking a little bit further, I said I will talk a little bit about each of the services. So local zones. So think about local zones as we are extending the cloud in all these metro and industry centers. We have 33 of these industry centers launched. We have 17 more coming up. And if you think about these areas, this is where we have deployed. Think about it's an extension of the region. Here you have your favorite services deployed. Except the difference from a region is these services are deployed in your city of choice there. And it really speeds up the latency to less than single-digit latency, as we call it. So what happens is your developers seeing a fast, low-latency access, if you will, for their applications. Customers see a much faster access. Now, what are the common use cases, categories for local zones? One is latency-based. So if you think about latency-based, these are applications that are highly sensitive to latency. So if you think about application types like gaming, for example, if you think about one of the local zone customers like Supercell, so if you think about their gaming needs, they need their applications to be deployed in certain centers where a lot of gamers are residing because they want low latency access in those regions. Another example is social media, where you might take your social media app, and depending on where your users reside, certain parts of the app can be in certain metros on a local zone hosted, right, which is close to your centers. And then the other example is location-based. Location-based could be multiple types, where you need to keep it in a certain location for data residency. Financial services is a great example of that, or public sector because of government regulations. Or also, in case of certain enterprise migration and modernization, even though you want to migrate and modernize your workloads can't leave your premises, so they need to be local. So these are two examples, categories of examples of local zones. Okay. So moving on from local zones to outposts. So if you recall, Outposts is the next click stop in the continuum. These are deployed on premises. Okay, this could be a customer's data center or a co-location facility. And Outpost comes in two flavors. One is the big rack. This rack basically, as you see, is 42U, 80 inches tall. It's built on the same similar infrastructure as AWS, and it has the same set of APIs and tooling. And then if your needs are much smaller, with the Outpost, we have the Outpost server in 2 flavors, the 2U server and the 1U server. Depending on your needs, if there is a lot of if there's space optimization needs, you can bring in the Outpost server instead of a full rack. So I'd like to talk a little bit about the Nitro security key. If you're not familiar with Nitro, we love the Nitro system. It's present in every server. And the Nitro system, effectively, what it does, it enhances the security model of the Outpost rack or server. And besides security, it also provides high performance, right? Now, one of the interesting challenges becomes when you're deploying these devices on premises, you want your data drives to be secure. And if you have managed a data center or a colo facility, you know that's a very hard value proposition. So if you have to manage drives, you ought to have a certain way of inventorying those drives, maintaining their recycling procedures, decommissioning procedures. It's very difficult to do. If a hard drive goes bad, you got to figure out how to take that hard drive, shred it, degauss it, and you got to do it not for one, but thousands and thousands of drives in the data center. So what Nitro does is effectively it externalizes all the keys for those data into this Nitro device, and it's kept in a chip inside the Nitro device. So what happens is the keys are not on the data drives, it's on this Nitro device. And if there's a need to basically invalidate all the drives because a server rack or an Outpost server or a rack is being decommissioned, you simply basically crush the key by turning the knob. And that's how basically you render these drives useless effectively. So you have a single place of command and control at the back of every server where you can control the drives within the server without having to inventory every drive. So that's a pretty cool feature. Now, I'll kind of end my section here, recapping a little bit some of these use case categories. I talked about data residency, low latency, disconnected workloads that Ramesh is going to talk about, and then also a little bit on private 5G. Ramesh has one example there on private 5G. So I'm going to round out my section with a couple of examples on data residency and low latency. So the first example is Philips. So if you think about Philips Healthcare, they're in the business of providing critical care. And critical care lacked predictive analytics to really facilitate what they call preventative care, right? So here, the business problem was how do you provide the best of preventative care to your customers so you get ahead of the problem? And that meant bringing in AI/ML on-prem. Philips had a disparate group of systems on premises, a lot of different storage compute systems, and which all had different APIs infrastructures. So Philips worked with AWS and centralized this all on Outpost. What it effectively did was now between the cloud and on-prem, you had the same set of APIs moving back and forth. This is the same set of infrastructure, the management tooling, the same control plane, right? So that made management easier. And because there was a single source of procurement, CapEx was also easier to manage. And finally, because the on-prem and cloud works together very well, the compute and storage was on the Outpost, but the AI/ML was in the cloud. So that kind of worked perfectly well together. And they drove to the business outcomes of delivering better care for their customers. Another example, this time in financial services, is the FAB, or First Abu Dhabi Bank. The bank was in a phase of digital transformation where they needed to transform the user experience for their banking customers while maintaining their data residency obligations and adhering to their obligations. So what they did was, in this case, they used Outpost to modernize their mobile banking and payment systems, and they deployed Outpost. In addition, they deployed all these workloads in modern workloads in containers on Outpost. And because the container workloads need to be having high uptime, they deployed these containers with a BCDR, business continuous disaster recovery model, with 2 sites. outposts deployed at both sites, one at Abu Dhabi and one in Dubai, right? So again, with the deployments of Outpost, the customer was able to save costs, have a single DevOps experience for the developers across the cloud and across on-prem, and also deliver a better accelerated and transformational customer experience for mobile banking. Okay, so with that, I'm going to come to the rugged mobile edge section and hand off to Ramesh, who's going to walk us through Snow. Thanks, Ramesh.
Thank you, Sid. So let's start with what is the rugged edge. And the rugged edge simply is edge locations where you, our customers, are running operations in unconditioned environments, usually outside a data center, where you've got a wide temperature range for your operations. There could be vibration based on that environment, dust, humidity, and those kind of things. It is also edge environments and locations where you do not have consistent network connectivity, or you may be completely disconnected in air-gapped environments. Or it could also be places where you need your compute and storage to be portable, to be mobile, maybe in the back of a truck, on a ship, or another moving vehicle, or just on the backpack of an operator. So and in these use cases, the Snow family is a good fit for our customers, where they can run their operations, store and process data that's generated at those edge locations. Some of these rugged use cases where our customers are using Snow devices today to run their operation, think about it on a ship where data is being collected from sensors, and the data needs to be processed on the ship, either for scientific research or oil exploration. It could also be on a cruise ship or a Navy ship where you're actually using the Snow devices to run the operations and workloads for multiple use cases on that ship. Think about factories, Industry 4.0 factories, where you're having edge compute on the factory floor for predictive analytics or to manage smart robots. Autonomous vehicles or autonomous test vehicles, these generate tens of terabytes of data per test drive from data collected from a lot of different sensors. Could be radar, could be LiDAR, could be cameras, and the data needs to be stored. A little bit of processing needs to be done at the edge, whether filtering, cleaning up the data, annotation, and the data needs to be moved quickly for that customer to get that data to their data lake in AWS so that they can update their simulations, train their ML models. So the AWS Snow family is a family of services which have secure and rugged devices that our customers use to run their operations at those rugged edge locations that we just talked about. And over the next few slides, I'll deep dive into the services within the Snow family, talk about the edge compute capabilities for Snow. I'll give some use cases where customers are using Snow today and how they're using those capabilities. And then I'll wrap up with some real customer examples where they're using Snow in those rugged edge locations. So at a high level, the Snow family, there's two main services, AWS Snowcone and AWS Snowball Edge. Each of these services come in different configurations of compute and storage capacity, and those give you options for your different use cases. Where customers use Snowcone today and Snowball Edge, they use it as an example, as an IoT hub, where data coming from sensors generated at the edge are captured. Customers can quickly do processing and analytics right at the edge location to gain insights into their data and make decisions based on those insights. They can run image processing or analyze live video streams based on those images and videos at those edge locations. They can run ML inferencing at the edge to make AI-based decisions. I think Sid alluded to it before. Customers run all their operations and can run all these applications independent of AWS for long periods of time. The data plane of the AWS services and the control plane of the AWS services supported on Snow are run locally on the Snow device. And that's why you don't need to connect back to the region to continue your operations. Of course, most of our customers use Snow with intermittent connection to AWS, where they can use it to update the software, update their applications, transfer data, but you don't need to. You could run your operations permanently disconnected from the AWS region. So let's dive deeper into AWS Snowball Edge and AWS Snowcone. AWS Snowball Edge is essentially a secure and rugged suitcase-sized device appliance that's got storage, compute, networking, and a select set of AWS services supported on the device. It's 49 pounds, so single person carry. I've carried it, but not very long, not for long distance. It is 45 pounds. There are a few different configurations of the Snowball Edge device. From a compute perspective, it supports 3 configurations, 32 vCPUs, 52, up to 104 vCPU. 2 different configurations for storage density, one at 28 terabytes, and then there's a newer, dense Snowball Edge device that can go up to 210 terabytes of storage. As you can see, it's got a rugged enclosure, and that rugged enclosure can, and with the NVMe storage on the device, you can operate a Snowball Edge in motion in places where there's vibration. Think about a back of a truck, on a transport aircraft, on a ship, and other areas where there's vibration. The use cases where customers use Snowball Edge today, it's used in those rugged edge locations. One example would be integrated private wireless and private 5G, so customers can run an entire private 5G core and RAN on the Snowball Edge and still have some compute power capable to doing edge compute and multi-access edge compute at that edge location. And our customers like the variation configuration available for compute 32, 52, and 104 vCPU, so that for their applications and their workloads, they can pick the right type of a Snowball Edge device based on their deployment. Maybe in some areas, for example, in that private 5G, if they've got a smaller cell size, a lower amount of data throughput, they can use the 32 vCPU device versus a deployment area where they need a lot more compute for higher network throughput management, they can use 104 vCPU. With the 210 terabyte dense storage Snowball Edge, this was recently announced earlier this year, and it's becoming very popular for our customers for edge storage use cases. In many use cases, you think about the rugged edge, the tactical edge, a lot of data is now being generated at those edge locations, and having a dense storage device allows our customers to store that data and process that data before they move it to AWS. Snowball Edge is also used by our defense and intelligence community customers at the tactical edge, where a device such as this provides compute, storage, and networking for operation the back of a truck, in military transport vehicles, on Navy ships, or just at the forward military base. And the newer Snowball Edge devices, the ones with 104 vCPU and the ones with 210 terabyte storage, all have NVMe storage, which gives you more durability and resiliency in the rugged edge locations, and also higher input-output throughput performance. And so both those devices, the 104 vCPU device that was launched about a year ago, and then the 210 terabyte storage device launched earlier this year, have turned out to be very positively received by our customers for those rugged edge use cases. Let's look at AWS Snowcone. It's an ultra-portable, secure, and rugged device. Weighs just 2 kilos or about less than 5 pounds. You can hold it in your hand. And our customers are using a device like Snowcone in many of those areas where they're capturing data at the rugged edge from robots, from drones, and they can make a a little bit of processing of the data at the edge, and then move that data to their data lake in AWS very quickly. So it's just got 2 vCPUs of compute, so you're not doing a lot amount of compute, but you can use it as an IoT hub, or in case of autonomous vehicles, you can do a little bit of filtering and annotation of the data that's captured from the sensors and move the data to AWS quickly. With both Snowball Edge and Snowcone, there's 2 ways to move that data to AWS. You can either, when you have network connectivity, you can use AWS Data Sync, which is supported on both Snowball Edge and Snowcone, to move the data or the results of your analysis to AWS over the network. Or if you're always disconnected, you don't have that ability to connect to a network, you can ship a Snow device back to AWS for offline data import into your S3 buckets. In the next few slides, I'll walk through some of the key edge compute capabilities for the Snow family for both Snowcone and Snowball Edge, and give you some customer use cases, how customers are leveraging those capabilities. First, I'd like to talk about security. For our customers, security is very important, especially in these rugged edge locations. They're storing data that's very sensitive for them. They're running their applications. And we're taking many approaches with Snow to meet those customer requirements for security from a perspective of data encryption, software, hardware, supply chain, and compliancy. Some of those approaches to help meet our customers' requirements for security are listed on this slide, and I'll walk through some of them. All the data that's stored on Snow devices is encrypted using a 256-bit KMS encryption key that the customer selects. The encryption key itself is not stored on the device for additional added-on protection. The Snow devices are tamper-evident, and we use a Trusted Platform Module, TPM 2.0. As you've seen from the pictures, the Snow devices have a physical enclosure, a secure physical enclosure that provides you with added protection and security. We follow a secure supply chain where all the components on the devices are known and tracked. The devices and the services are FedRAMP High, compliant and certified for FedRAMP High. The devices can support IL5 and IL6, so US secret workloads. And you can order Snow devices, Snowball Edge, from AWS secret and top secret regions. And even though you can operate your Snow devices at the rugged edge permanently disconnected from AWS, we provide you the ability to update and patch all your software while you're in the field. When you're connected, of course, you can use the network to update your software. If you're not connected, then we will help you to do a sideload update of all the software using OpsHub. I'll talk about OpsHub in a later slide. So this gives you the ability to always update your applications. If there's any security vulnerability, we can provide you with the patches. We will notify you so you can update your software. And at the end of your workload, when you return the Snow device back to us, we clean all the data stored on the Snow device. We clean all your workloads, all your applications using a NIST-compliant secure erasure process. With direct network interface or DNI capabilities, the Snow devices and Snow services support multicast streams, load balancing, routing, and other network functions that allow the instances on the Snow devices to directly interface with the external network. And using DNI on Snow, the instances on the Snow devices that are running on the Snow devices have a direct layer 2 networking interface to the external network without any intermediary translation or filtering. And for our customers, what that means is that they're able to customize their network configuration, and they can also achieve very high network throughput. To use DNI on Snow, you create a direct network interface. You can associate it with one of the physical network ports on the Snow device, and then you can attach the DNI to one of the instances running on the Snow device. You can create VLAN tags for the DNI, and you can associate multiple DNIs with a physical network port on the Snow device, and you can associate multiple DNIs to instances running on the Snow device. And you can also, the customers can also customize their MAC address. It gives a lot of configuration capabilities. Where DNI is used by our customers, both in tactical edge as well as in telco use cases, they can use DNIs to set up multiple DNIs per instance for their network ports, achieve very high network throughput. From a physical network perspective, Snowball Edge can support 100 gigabits per second network throughput, and we're seeing customers especially in the telco use cases and even tactical edge, achieving many tens of gigabits per second of throughput in their actual application. So how do you manage these Snow devices that are deployed at the rugged edge, operating at the rugged edge, and they're not connected back to region? You can use AWS Ops Hub, which is a graphical user interface or tool to manage multiple Snow devices operating at those rugged edge locations. AWS Ops Hub, the tool itself runs on a local host. Think about a laptop that's connected to the Snow devices in the same local area network. And you can use Ops Hub to set up and configure all the Snow devices at that rugged edge location. So think about setting up the network configuration, unlocking the devices. You can manage all your workloads. So you can manage your EC2 instances, your container workloads, your IoT functions. You can start and stop different applications. You can reboot a device, all of that using Ops Hub connected to multiple Snow devices. You can monitor the resource usage, so the physical resources on the Snow device, the vCPUs used, the storage that's remaining storage available. You can monitor the health of all your applications. And you can use Ops Hub to update the software. You can update, like I said, when you have connectivity, you can update your software over the network, or when you're not connected, you can still use Ops Hub to update the software on the Snow devices. And that could be you're updating your applications running on the Snow device, updating the Snow software stack itself. Essentially, what you would do when you're not connected is you would download the updates from the console onto that local host that has Ops Hub and bring that local host to the Snow devices, and then you can update your software on the Snow devices. And we're adding a lot more capabilities in Ops Hub to help you manage more intuitively a large deployment of multiple devices. We'll provide you with notifications when software updates and patch updates are available, so you can make those updates. Ops Hub will also let you know when you need to update your certs. So all of that information will be provided on that local host running Ops Hub. Talked about customers running applications, image processing, ML inference, data analytics on Snow devices. So the Snow devices support a select set of AWS services for compute, analytics, containers, storage, access, security, ML inference, and data transfer. And when we say an AWS service is supported on Snow, it means both that control plane and data plane are supported locally on the Snow device, which is what allows you to run your operations disconnected from the AWS region. Each service is just a subset of the API is supported on the Snow device, not the full API set. But for the APIs that are supported, it is API compatible with the service in region. And this is what would allow our customers to say, build their VMs as an army on EC2 in region and deploy it on an EC2 compatible instance on the Snow device. Similarly, you can take your containers, build it on EKS in region, and deploy your containers on EKS anywhere running on the Snow device. For serverless applications, you can develop your IoT functions or Lambda functions in region and deploy them on the Snow device. For AI ML type use cases, you can train your ML model on SageMaker in region. And then we've got SageMaker Edge that's supported on the Snow device. So now you can run ML inference at the edge using SageMaker. Storage is supported with EBS API compatibility for block storage and S3 compatible APIs for object storage. And in a lot of those use cases at the edge, the customers are capturing data, processing the data at the edge location because they want to gain insights quickly, make decisions quickly. But once that's done, there may be a need to move that data to AWS, to the customer's data lake for either additional processing, or maybe just move the data to AWS for archiving, or in some cases, customers just move the results of their analytics to AWS. And that's where Data Sync will help you when you have network connectivity, either consistently or intermittently. You can use AWS Data Sync to move data or the results of your computation or analytics to AWS. So we talked about the different workloads that you can run on AWS. So how do you get your applications onto the Snow device? So for your virtual machines that maybe they're developed at the edge, not in AWS, the way to bring that onto Snow devices, there's two approaches you can follow. One is you take your virtual machines and you create an Amazon AMI running on EC2 in region. And we provide you the equivalent EC2 instances between the Snow device and EC2 in region. For example, the instances supported on Snowball Edge are equivalent to the M580 instance in region. So once you've developed your application as an ARMY in EC2 and it's validated, when you order a Snow device, you can request for those ARMYs or to be installed on the Snow device, and we would install it and ship it to you. Another approach is you can update your application in region or bring new applications to your Snow device in region. And in this case, you're just effectively importing a VM image onto the Snow device in region or in field at the edge. And you could use Ops Hub to make your life easy to import that virtual machine onto the Snow device. So that's what I talked about, basic compute applications running as virtual machines on Snow. We're hearing from our customers more and more that they want to run container applications at the edge. In many industries like telco, in retail and automotive, and even in defense, given the US DoD initiative with Platform One, we're seeing our customers modernize their application by transitioning to a DevSecOps approach and transitioning their applications to a containerized approach. So on the Snow devices, of course, you can support containers using EKS distro, or you can support it using an open source Kubernetes kind of approach. To make it simple and easy for you, we do support EKS Anywhere on the Snow devices, and you can use EKS Anywhere to set up, create containers. EKS Anywhere provides you the capability to set up multi-node clusters across many Snow devices. And that way you get high availability and fault tolerance. We're also working with our partners. Think about partners like Rancher and Rafe, who've got multi-node container applications and management type use cases, both in region and now supported on the Snow device. So if you'd like to use those partner applications to manage your containers, that's an option available to you as well. One of the new use cases we're seeing this year is we're seeing our customers request for the ability to support large amounts of data being stored at the edge, many petabytes of data. The data is being generated from sensors. The data needs to be collected. The data needs to be processed and analyzed at those edge locations so that customers can gain insights and make decisions in near real time without having to move that data to AWS. Eventually, that data may move to AWS to be for further analysis and for archive purposes. So earlier this year, we announced S3-compatible storage on the Snow devices that can support clustered edge storage going from 3 to 16 nodes. And for those edge storage use cases, if you use the dense Snowball Edge storage with 210 terabytes, you can see how going up to 16 nodes, you can support many petabytes of data at the edge location. The S3-compatible service is designed for durability, and it's redundantly stores data so that you can kind of recover from disk failures on the Snow device or a device failure in a multi-node cluster. The service is, of course, compatible with the S3 API in region and same bucket management policies. So it makes it easy for you to take your applications, your data management applications that uses S3 in region and use that on the Snow devices at the edge. And I kind of touched upon this earlier. With AWS Data Sync supported on the Snow device, you have that ability when you have connectivity, you can move data between region and the Snow device at the edge. Either you can import data from the Snow device from the edge to AWS or export data down from AWS region to the Snow device. And based on your rugged edge location, if you don't have a terrestrial network connectivity, we offer a few different approaches with our partners. We have, with for example, satellite connection. We are working with partners like Starlink and Viasat, so you can have a satellite connection between the Snow device deployed at the edge back to AWS region. You can use private 5G or another mechanism to move that data between the Snow devices and region. And some customers also keep additional Snow devices with them on rotation. So one approach you can follow is once the Snow device is full of data to 10 terabytes or 80 terabytes, you can physically ship the Snow device back to AWS for that data to be copied, while the next set of devices may be collecting and processing the next set of data that's generated at those edge locations. So for this next section, we'll just focus on some of the new capabilities we've launched this year for our public sector customers, especially for tactical edge, for defense and intelligence community use cases. So earlier this year, we announced a new Snow service called AWS Snowblade, which is, as of today, just available to our defense customers as part of the JWCC contract. And the AWS Snowblade is kind of like a toolbox-sized device, very dense in compute. It's got up to 208 vCPUs of compute. It's the densest compute for a Snow device. It's also server rack form factor, short depth, 17-inch server rack form factor. So it's the first Snow device that's in that server rack form factor. The reason we took this approach is we're seeing a lot of our customers use Snow devices in isolated data centers. So they have server rack infrastructure, but because they're running their operations in an isolated data center, they can't connect back to AWS. So they're looking for a device such as a Snowblade. Many other use cases with large military trucks, transport aircraft, Navy ships, they have that capability to support those short depth, rugged, rack form factor devices. Snowblade also has an optional enclosure. The graphic here you see on the slide shows it with that optional enclosure, which is MIL standard 810H certified. So now when you're operating Snowblade outside of that isolated data center, maybe at the back of a truck, maybe at the forward military base, you can use that MIL standard 810H enclosure to provide additional ruggedization and protection. And just given the nature of the device, what we're seeing a lot more use cases where more complex workloads are being used by customers at the edge, AI/ML inference that needs a lot more compute, and that's where a 208 vCPU type device comes in use for our customers. I talked about, in the previous slide about a use case where customers are looking to store multiple petabytes of data at the edge location using multiple Snow devices. We're increasingly seeing our customers run more complex workloads, needing multi-node containerization, multiple Snow devices to run those complex workloads, or multiple Snow devices operating in a cluster to store many petabytes of data. So we're offering our customers a full rack integrated solution with those Snow devices. Could be Snowball Edge with 104 vCPUs, Snowball Edge with 210 terabytes of storage, or Snowblade. Each rack level solution can support 6 Snow devices. The rack supports redundant top of rack switches. We will set up all the redundant cabling. We'll set up the L2, L3 network configuration. It provides some redundant power modules, a firewall and switch management. And when you come and order from us a full rack solution, we'll integrate it with all the 6 Snow provision devices, set up the cabling, network configuration, ship the fully integrated solution to your edge location, and help you with deployment. Many of our customers are also looking to deploy multiple of these racks, just given the nature of their application. Sometimes you'll have a few racks of compute nodes, then a few racks for disaggregated storage, and we'll help you set that up with data center gateway and redundant spine switch connection. And in many cases, customers are using that multi-node containerization, like as I mentioned, to set up their compute workloads, or with 6 dense Snowball Edge devices with that S3 compatible storage that we talked about earlier, you can do 1 petabyte of storage for each one of these rack solutions. Take it a step further beyond rack level integration and solution. Earlier this year, we announced AWS Modular Data Center, or MDC, to make it very simple for our customers and cost-effective for them to deploy an AWS-managed data center anywhere they need it. So if you think about it for our defense customers, especially in outside the US or OCONUS locations, where they don't have infrastructure, or if they were to set up infrastructure, they're constrained by the amount of compute and storage and networking they can set up, or they may have to spend 2 years setting up a new data center. Using an AWS MDC, the customers can quickly deploy many thousands of compute cores and the ability to store many petabytes of data. So the AWS MDC is a secure, environmentally controlled physical enclosure that can support up to 6 Outposts racks or 6 racks of the Snow devices, the similar solution that you just saw in the previous slide. You can mix and match. You can have some Outpost racks and some racks of Snow devices as well. And if you need even more compute capability, you have the ability to scale up and deploy multiple of MDCs at those edge locations. Customers, the only thing they need to provide is power and a network connection if you're deploying Outposts, since Outpost needs that network connection. And as you can see from the graphic, the MDC does support the ability to have satellite communication. We recently announced SES as one of our first partners who will support satellite connectivity to the MDC. And the MDC itself is easy to transport. It comes as 2 modules of 20-foot containers, so you can move it on a trailer truck, on a military transport aircraft, or on a Navy ship to bring it to the edge location. So I'm going to wrap up with a few customer examples. The first one is AWS disaster recovery team collaborating with our partner and customer help.ngo to really bring the capabilities of Snow, the disconnected operation, to help first responders in disaster recovery areas where there's maybe an earthquake or a tornado or a hurricane, and therefore there is no consistent power supply or network connectivity. So what you see in this truck is there's a Snowball Edge devices deployed. Help.ngo has developed a lot of software for image analysis, video analytics, and ML inference that's been loaded onto these Snow devices. So we send drones in the impacted areas. The images and videos from the drones are analyzed on the Snow devices to provide first responders with information on where they should provide their assistance. We also set up an IoT hub with sensors on the first responders for safety and tracking and location. It also supports encrypted communication using Wickr. You can see the disaster recovery truck or Jeep at the Venetian, so please go take a look. And there's also on the Casanova floors, on the first floor on the Venetian, you'll see a demonstration with Wickr on Snowblade and Snowball Edge. Just recently, we collaborated with NATO's Allied Command Transformation Team, and they showcased how you can create new hyperscale technology and combine that with Snow devices for operation at the rugged edge. And effectively, what the NATO Allied Command Transformation Team did is they combined next-generation communication technology with AWS Snowball Edge to allow the warfighter to capture data, analyze it quickly, gain insights, and make decisions at the edge. It also helped improve the ability for NATO to collaborate with their multinational force. Another example of operation at the rugged edge with showing data analytics and also a full private 5G network running on the Snow device is with the Norwegian Army, where they created a network on wheels. So here you have a Snowball Edge with 104 vCPU running a full private 5G network, core and RAN, developed by our partners, and it still has additional compute capability to do edge compute, such as video analytics and image analytics. And you can see the Snowball Edge is, with that private 5G and edge compute is deployed on that mobile trailer, so that can be pulled into a disaster recovery area or to a forward military base, so that you can do very quickly in an area where there is no consistent power or network connectivity. You can capture data from sensors, from drones, and do analytics, make decisions to support the mission, and send data back to AWS. All right, so that's about wraps up our presentation. We've got about a few minutes. I'll invite Sid to come back up on stage and be happy to answer any questions you have. And of course, after this presentation as well, we'll be here. You can see our emails. Feel free to reach out to us later today or send us an email with any questions you have. And please complete the session survey as well.